So up until now, over the course of this class, everything that we've done has been in a mass form. So we're talking about solids or gases, or liquids. We've been using things in grams. Or we've had, if we've had volumes, we've been using density. But our calculations have been, we've done everything using mass. Now, we're going to talk about reactions that occur completely in solution, meaning things that stay in liquid the entire time. So let's talk about solutions. You've probably done this before, probably in elementary school, maybe middle school, but what is a solution? A solution is a homogeneous, meaning it looks the same, mixture. That would be two or more substances that are not chemically combined. So the solvent, that would be the major component, the liquid usually. Solute would be the minor component. Our major component is going to be usually water. This is what does the dissolving. The solute is what is dissolved. Now, solutions are usually expressed in terms of a concentration. Now, when we get to next semester in Chemistry 180, we'll talk about lots of other ways to calculate concentrations, but the most common is molarity, and that's done with a capital M. So molarity is defined as the amount of solute in moles per volume of solution in liters. So molarity is a derived unit. Write that on your conversion sheet. So the abbreviation here, molarity equals moles in the top, liters in the bottom. So what I like to advise is anytime a question gives you a big M, cross it out and write moles over liters. So make sure you do things in a vertical fraction. So molarity means moles over liters every time. You have to memorize that. You have to learn it. Now, so we can use this to calculate solution concentrations. So what if we dissolve 25.5 grams of potassium bromide in water, and that gives us 1.75 liters? What's the concentration? All right, so when it says what's the molarity, that means in our final units we want moles on the top and liters on the bottom. So use that when you're constructing your calculation. Now, there's several ways you can do this. If you say, oh look, there's liters, and I know liters needs to go on the bottom, put it on the bottom, 1.75 liters, then you know it's there. Okay, and now we know we need moles on the top. Do we have moles in here? We don't. But we do have grams. So let's start with 25.5 grams of KBr. And you know what? Sometimes you do this, you're going to get it upside down, and that's okay. Trial and error. Use your eraser, just write it again. When you're dealing with things where you got to have units in the top and the bottom. Okay, so let's find a molar mass, KBr. Potassium, 39.1. Bromine, 79.9. So I get 119. 119 grams KBr, 1 mole KBr. Okay, grams cancel out. Now, do unit check. We want moles in the top. Moles is in the top. Liters are in the bottom. Again, it doesn't matter which order you put this in. So let's multiply it out. 25.5, nothing else in the top, divided by 1.75, divided by 119. So 0.122. 0.122. Now you can go ahead and write moles per liter. That is an acceptable answer. Or you can say 0.122 molar. This is how the abbreviation stands for molar, is how you say that. Both of these are correct. Pick the one that makes the most sense to you. I recommend doing this if you haven't done it before until you get used to it. Let's try another one. Molarity of the solution. Here we're going to add 45.4 grams sodium nitrate, dissolve it in water. Total volume of our solution, 2.5 liters. So this time I'm going to start with grams on the top, just to show you it doesn't matter. NaNO3. Now we want moles in the top, so we know we can use molar mass. Sodium is 22.99. Nitrogen is 14.01. And 3 oxygens. So I get 85 grams NaNO3 gives me 1 mole NaNO3. And now, so I have moles in the top, remember? Okay, so we want molarity. That means I want moles over liters. And 2.50 liters. Do a unit check. Moles are in the top, liters are in the bottom. 0.4 divided by 85 divided by 2.5. So 2.13. Did I get that right? Yeah. 0.21, well, 214, sorry. Moles per liter, or you can say 0.214 molar. Both of those are correct. All right, now let's look at this a different way. How much nitrate is going to be in each of the following solutions? This is going to be interesting. You haven't done this before, but just think about what you know. You can figure this out. If I have 0.15 of each of the following, and we want to know how much nitrate. Now, so this is sort of like how you would do, you're going to do this a lot like a mass percent in a way. That's the best analogy to something we've done before. So here we have 0.150 KNO3. Now, look at your formula and you say every one of these, so has how many nitrates in it? 1. So that's the same. So it would be 0.150 molar NO3 minus. Now look at the next one. We're all starting with the same concentration, 150 molar. Now, every one of these, so 1 molar here, CaNO3 so this would be calcium nitrate, has how many nitrates in it? 2. So there's twice as much NO3. So here, that cancels out, so twice as much, 0.300. That's supposed to be a 3. Now, because aluminum is plus 3. 0.150 molar aluminum nitrate. This time, for 1 molar aluminum nitrate, there's 3 moles, 3 molar of nitrate. So the amount of nitrate that's in the solution is actually 450. So this is sort of a way to to compare how much of a component of the solution is in there.